going to give a quick code walkthrough, and then at the end, I'm going to go through some of this system that we are talking about as well. Yes, this information is on the GitHub. So if you want to review this later, you should be able to take a look yourself as well. So this one is a notebook. It will show you how you getting the information from pipecone through the similarity search, and then how it's using a ranking system to build the ranking. So first you see here, we will need to import pipecone. Sentence transformer is from Hugging Face, is for the model, embedded model I'm talking about. And I have the business export. So this is the model that I already trained and then uploaded into GitHub. So you can see that on the GitHub as well. It's a trained ranking model. And then after this, you starting to download the business export. That's the model trained to do the ranking. And here you need to get and then after that, we're using, remember the first thing to do is get a top 20 match or the semantic search. So the top 20 match is running against a pipecone. So we already have putting all the information of business into pipecone vector database. From here, you make sure that you initiate, get the pipecone client. After that, we need to embed it. Get the embedded model. So in this case, is using the sentence transformer from Hugging Face. This is the embedded model, or there's MPNet. HBase V2 is one of the best right now for semantic search. So here, I'm going to walk through this quickly. So this is a query, Italian restaurant in Tampa. And then you need to first encoding the query. When you say encoding the query, what does that mean? Remember when I'm talking about embedding, we already embedded all the business category information in the vector database. In order to do a similarity search, we need to embed the query as well. And then based on that, we can do the similarity search using cosine similarity. With that, we should be able to then get a filter set of matches. In this case, we want to put 20 of them to return. So you got 20 of them to return. This is the match return. So here you've got 20 restaurants here. This is 20 restaurants that you match based on what you have entered. This is 20 restaurants in Tampa after you run it here. So you have 20 with a score, individual score, but this is just based on the semantic search, similarity search. It does not take the personalization information of the users. So which one do they really like? Which one they, based on their previous selection, based on the previous search result, how can we know which one they really like out of that 20? That's when we start using the model. This is the model we're talking about business export. It's the model we downloaded and then loaded the model. And use that, we enter the 20. So in this case, if you look at this, we have the 20XC. This is from the previous search, top 20 match. Then we'll be here, we're going to look for the metadata, the tax information. We're going to start using what the model has providing us to generate the information. This is actually just printed out as a matter of fact. The next one is actually what we're going to do is the model with matching. So in this case, the model, we're taking the array of this information, and then we're going to go ahead and then return all. So this is one of the user. I'm going to go through this one more time. So the user ID is one of the users that's in the database from the Yelp sample data. And then this is the business ID. This is the business ID from the top 20 that we send out from the top 20 search over here. So which we filter it out, we got that top 20 out of here already. So the top 20. And then we pass into the model, we pass in the business ID, we pass in the user ID, one business ID, 20 business ID, one user ID. Then you're going to read the model, going to return us the ranking, and then we sorted the ranking by sorting this. And this will give you all the 20 restaurants they asked in Tampa, and then based on your personal preference before in the system, we sorted and then recommend this to. This is the top 20 return that is sorted. This is the overall POC. Keep in mind, there are few technology we use here. One is the vector DB pipecone that can store the vector information for similarity search. And we have a model for embedding that can be used to embed the word, the sentence, and the query. And lastly, we have a TensorFlow recommender system that will do the ranking. All in all, that should give you an overall good sense how a ranking system, recommendation systems do. Thank you very much and have a good day.